I don't think the industry was going down a path of fulfilling that sort of promise of peer-to-peer electronic cash. If it wasn't, privacy not being there or scale not being there while maintaining some form of decentralization. Uh, so that ultimately led me to want to develop Quai, which is, a scalable proof-of-work systems. Sort of maintain uh, the really good characteristics of Bitcoin, a la proof of work, relating the minting cost of a token to actual energetic input costs, as well as having a relatively decentralized system, but taking that to scale so you can actually use it as peer-to-peer electronic cash.
Welcome to the DevNTell podcast, where founders, hackers, and anyone in between showcase their products built on the bleeding edge of tech. GM, and Happy New Year, Dr. K. Welcome to the show. Excited to have you on, man.
Yeah, Happy New Year to you too.
Excellent. Thank you so much for taking the time of your day to come chat with us. Really excited to learn about Quai Network. I know a lot of folks tuning in today are as well. But I guess before we get into all that good stuff you have prepared for us, would you like to give a brief introduction for yourself?
Sure. Yeah, my name's Dr. K. Been in the crypto space, at least as a hobbyist, since about 2012. I've been working full-time since 2017. Kind of got my full-time start at Consensus, did a spin-out called Good Plus, designed and built the Lattice 1 hardware wallet. Sometime in 2018, came up with this concept of how to scale proof-of-work blockchain. So I managed to actually get a National Science Foundation grant to work on that as sort of like a research project that was after I graduated my doctorate in engineering. So it was kind of like a postdoc projects kind of thing. And that eventually turned into a full-time thing. So been working on Quai full-time since 22. And it took us from concept in 2018 to implementation, or mainnet took about 7 years. Full-time, it was about 3 years to sort of implement Quai. So that's kind of my background, or at least in crypto.
Awesome. And I guess what was the compelling thing that kind of brought you into the world of crypto? Like, what was the thing? Like, oh wow, this is like really cool kind of moment that made you want to like be here full time?
Yeah, so from my perspective, right, Satoshi really just summed up in the title of the white paper, peer-to-peer electronic cash, right? And the sort of libertarian underpinnings of that, and obviously relating that with proof of work, meaning you have like a physics-based money or an energy-based money in some way, certainly answers a lot of the questions related to rampant sort of monetary policy and political corruption. So, all of those sort of ideas about, money, politics, and society and individual freedom is what drew me into the space. In terms of kind of where I saw it go after 2017 is, it's a very technically challenging problem, but I don't think the industry was going down a path of fulfilling that sort of promise of peer-to-peer electronic cash. If it wasn't, privacy not being there or scale not being there while maintaining some form of decentralization. So that ultimately led me to want to develop Quai, which is, scalable proof-of-work systems. Sort of maintain the really good characteristics of Bitcoin, a la proof of work, relating the minting cost of a token to actual energetic input costs, as well as having a relatively decentralized system, but taking that to scale so you can actually use it as peer-to-peer electronic cash. And then obviously to do that, you also need some privacy features. But that is, wanting to actually see that vision brought to true life is really what motivated me to start Quai.
Awesome. And you didn't found Quai Network alone, right? There's a couple of co-founders, if I'm not mistaken, that came along for the journey with you. And in particular at the University of Austin, as you mentioned, I find that really interesting, like how such a big network kind of started out of a university. That's not usually the traditional startup route, right? would you want to get into that just a little bit? I'd like to hear the that kind of story there.
Yeah, so I got my engineering degree at UT. So I finished in like early 17, uh, my doctorate, and I kind of came up with this idea how to scale proof of work in 18, and I shared it with one of the professors that I knew at UT. So he kind of had a research group in electrical engineering, looking at distributed systems. So he's like, yeah, let's start looking at this. He had a couple grad students, a couple undergrad students, uh, and we kind of started working on it. And I got that National Science Foundation grant, and and then eventually in 22 we managed to raise money from Polytree Capital, which allowed us to really go like full time into it with a much bigger team. So that's kind of how it started. Yeah.
Cool, cool. Yeah, that's amazing. And yeah, I guess no better time than now to kind of get into the details of this. So one of the big things I've seen reading up on Quai Network is this notion of proof of entropy minima, PoEM for short. Can you just explain what that is and why you guys think this is better than traditional proof of work?
Yeah. So to get to PoW, I just need to give a little bit of a background. So Quai is a hierarchy of merge mined blockchains. So essentially, what we do is, if you're familiar with like a super block, uh, it's kind of like this concept. When you're mining a block, you can hit a difficulty, right? If you hit the difficulty, you find a block. But then you can have a concept of a super block, which is instead of just meeting the block difficulty, what if I meet the block difficulty plus like 5 extra zeros, right? Then what we can do with that is we can make like a super chain. So you kind of have like this lower chain, then you have like an upper chain, you have a chain above that. We call that prime region. And then what that allows us to do is it allows us actually to create a pyramid of chains where prime is at the top, then you have regions below that, you have zones below that. Now, then what ends up happening is as a miner, you have to sort of operate a slice, meaning anytime you propose a header, you have to propose a prime, region, and zone sort of composite header. And then depending on what difficulty you get, you'll either get a zone block, a zone region block, or a zone region block. And that's how you have sort of like multiple threads, but they're all working on a common consensus layer, which is just proof of work. And what PoEM does is it allows a deterministic outcome without multiple rounds of communication. So in traditional proof of work, you can get a fork, right? And basically what happens is it's a natural thing the system sees because once you find a block, it takes time to propagate throughout that system. During that propagation time, someone else may find a block, just like a very super honest orphan, as we might think of it in Bitcoin, or an uncle in Ethereum. And so the problem with that though is that you'll eventually get resolution, but it takes time. And so as we add more of these threads, so to speak, more of these shards, the ability to wait to get like the canonical tip limits the total number of shards you can have. Because if I'm in one shard, and like statistically, maybe it takes me sort of like 30 seconds to kind of know that we're all in agreement. And then I have another shard, it takes 30 seconds to agreement. Now, when I start trying to go back and forth, and this aggregate, I have this like aggregate composite agreement time, which may be like a couple minutes, right? And then as I keep adding shards, like it just gets longer and longer and longer in time. So what you really want to do is you want to make sure that your consensus mechanism is deterministic, so we don't have to have rounds of communication. This sort of statistical convergence. We want to converge as quickly as physically possible. So basically, what PoEM does, instead of just measuring or rewarding blocks, the difficulty threshold, it uses the whole, basically. And we basically take the field size minus the whole hash, and we take a log of that. And then we call that bits. So, a Bitcoin block has like 60 leading zeros. So that would be like 60 bits. But depending on sort of how lucky you get when you find a block, you'll get some fractional bits. So it'll be like 61.25684, whatever, to whatever precision you took your logarithm, right? Or you might even get lucky and you'll find 64.89257 bits. But the interesting part here is because you're maintaining the sort of randomness of the field, you basically have a guarantee that everyone will choose the same winner uh, to the point of a hash collision. So like if two blocks are mined, unless they like literally collide, there will be one better block than the other, and the betterness or the weightiness of that block adds up over the sequence, if that makes sense. So what PoW does is it allows a deterministic fork choice rule that is also compatible with extending not just one but many chains simultaneously.
Wow. Yeah, that's amazing. And that I suppose that took quite a bit of testing on a test net, and a lot of back and forth and revisions until it got right. And
Yeah, well, so what ended up happening, to be honest, is so Quai kind of like evolved over time, right? Um, the very first thing that like started Quai was the concept of just the hierarchy merge my chains, and we kind of like built that. And then when we got there, we hadn't really thought too deeply about consensus. We had come up with something that we called the hierarchical longest chain rule, which was basically saying like we'll pick the heaviest prime, then heaviest region, then like heaviest zone sequentially. But that actually creates like an unresolvable loop if you have many chains that are propagating in time. So you can get these situations where you're sort of like trying to compete with the chains, and you need to resolve who the leader is, because in this system, prime is not the leader, prime is the follower, right? The leaders are simultaneously all of the zone chains, right? So it's a multi-leader system. And the nature of that multi-leader system required us to figure out a way to create a deterministic choice rule that would be compatible with having many leaders, right? And that's kind of where PoW came from. So we actually built the system and spent like a couple years putting it together before we realized we needed something like PoW, and we were just lucky enough that we could figure something out that actually kind of worked. There's sort of like an interesting like a knife's edge that we're kind of balancing on, and that depending on like how academic or how theoretically minded you get, there's this concept of like synchrony versus asynchrony would be our sort of assertion that we're very much on the edge of asynchrony here, because you have a many leader system, and then this rule will always resolve out once everybody sees the data. So given consistency, we can guarantee consensus, and that like technically should really exist within sort of the theoretical frameworks that have been proven within information systems. So we kind of got lucky, I guess, would be the statement.
Amen. So sometimes you just need to get lucky that one time, right? So, um, and yeah, I guess a couple things before we move on. So, just curious, like what like most of the, at least on the Ethereum side of things, most of the industry has moved on from proof of work to proof of stake. Like what was a determining factor from your guys' end where you're like, no, we don't think proof of stake is the future, and you guys wanted to iterate on proof of work?
Yeah, so there's kind of like there's kind of like a very visceral sort of divide between proof of work and proof of stake, and it has to do with the fact that proof of work, at least instantaneously, is hard money, right? So like in a proof of work system, so like let's talk about gold. What gives gold value? The thing that fundamentally gives gold value is the energy that goes into finding, mining, and refining it. So over time, sort of the market value of gold is the cost of producing gold. In proof of work, at least instantaneously, that is true. So like if you look at Bitcoin, right, the cost of making a Bitcoin is the cost of a Bitcoin instantaneously. Like that's kind of, it trends to that. So that property of hard money, is very much part of it, right? And then the property of immutability, meaning economic immutability, right? So something just becomes inordinately expensive with time to ever go back and change, versus having a committee being able to effectively re-sign some things to change history, which doesn't have a high economic cost. That's kind of initially kept us focused on proof of work. what I will say is the nature of poem and the nature that it is uniquely derivable from work and really nothing else, actually makes proof of work much more scalable and much faster. I cannot find an analog in proof of stake that would allow a many leader system like we can do with poem. So you can't even scale proof of stake to the same degree that you can scale proof of work. And one other way to think about that is with poem, we never have to talk about which block to pick. We just need to broadcast the blocks to each other. With proof of stake, we have to talk about it, right? So like I have to get a proposal, I have to sign it, then I have to send it to you, then you have to sign it. And then we have to aggregate the signatures and be like, okay, quorum, now we're good. With proof of work, it's a broadcast only system. So like once the block hits everybody's nodes, like because the rule is deterministic, we all know that we're in agreement. So there's no need to talk. We just need to make sure that we see all the blocks, right? So it's a much, much faster consensus mechanism, and it's a consensus mechanism that allows this sharding because it's deterministic. You can't recreate that in proof of stake. And if you try to, you actually get a system that turns back into mining. Because I've thought about this actually quite a bit. So if you tried to use signatures to do this, you would actually get people grinding signatures. So it would devolve right back into mining.
Fascinating.
Yeah.
And yeah, I guess you kind of touched on it as you were explaining, but just the scalability factor. I was reading up in your guys' documentation that this poem consensus mechanism kind of solves the blockchain trilemma, right? Of being able to kind of scale a blockchain. Is that true?
Yeah, so basically what happens is within that hierarchy, you kind of have different parameters, so to speak, in like your sort of trilemma. But because it's all in one system, you get like the best of everything because you can put points in multiple parts of the triangle, if that kind of makes sense. So what ends up allowing us to scale, right, is we have like a zone chain and we're operating at 5-second blocks. And so you can get Visa, MasterCard like settlement times in one of these chains. And then, one of those chains, we can do around 700. We can probably go more than that per chain. But let's just say 700 for right now. Now, then what's interesting is because of poem and because of this hierarchy, once you have like chain fully saturated, you just kind of add another chain. And they coordinate via the next sort of what we call a dominant chain, so a region or prime. And so you can just keep the system expanding and all these chains are still interoperable with each other because they're all still running the region and prime chains together. Now, the sacrifice here is that if I want to do a cross-chain transaction in these zones, there's some clearing time for that. But if we went to say like the whole Western world is using this thing, sort of your worst case, well, I wouldn't call confirmation, I'd call it settlement time, which is different, is about 90 minutes. So if you're sort of like in the worst case, farthest zone away from me in the world, and I try to send you money in this situation where everybody with the internet is like using Quai as a means of payment, you would in 5 seconds know that I paid you money. But it might take 90 minutes for you to get that money in a way that you can respend it, if that makes sense. So that's like the sacrifice. But that, again, is if you're doing 100,000 transactions per second constantly, and you're at this like 100 shard topology, you might have to wait 90 minutes to be able to respend your money. You're still going to get that 5-second payment guarantee, but you'll take 90 minutes to spend it. Now, compare that to today, when you actually like pay a merchant with a credit card, it can take them 90 days to see that money. Right? So, I don't think like that 90-minute sacrifice is actually a sacrifice at all, right? As long as you're getting an economic sort of confirmation within 5 seconds, like you're good. It's just waiting 90 minutes to be able to respend. There's very, very few economic use cases that need that high velocity of money. So we don't even really see it as a compromise, to be honest.
Yeah, that doesn't sound like a compromise to me. It's better than a wire transfer. And yeah, like you said, 90 minutes versus 90 days.
Yeah.
90 day.
Well, and the other thing too is what we see is that the way the system is set up is it actually encourages geographic subnetting relative to the shards from both a node and miner perspective, as well as a transactor perspective. So what you might see is that as the system grows, maybe the East Coast is in one shard and the West Coast is in another, right? So then when you're in New York and you're buying your bagel because you're from New York, not only are you confirmation in 5 seconds, the merchant's going to receive their money in 5 seconds. It's only when you go to like the West Coast, it might take 20 seconds. And then when you go to China, it might take like a minute for the merchant to actually get the money, but they'll still know that they're getting the money within 5 seconds, right? So that like 90-minute problem is only going to be like the absolute worst case when you're in a very unoptimized situation. But the incentive of both the users and the node runners is to aggregate together, right? So in most cases, even with the system scales, 95% of the time, you're still not only going to be getting confirmations in 5 seconds, you're going to get settlement in 5 seconds because you're going to be in a common shard.
That's amazing. That's pretty nifty. Not gonna lie. I guess shifting gears just a bit to the development side of things. It seems like Quai Network is an EVM compatible chain as well. So for the EVM developers watching today, how easy is it for them to take their existing smart contracts and deploy it on Quai Network? Is there any anything that the EVM doesn't support on Quai Network?
So the only difference is that we have a sharded address space. So we have variations of hard hat and VM that like allow people to sort of port their contracts over. They just have to deal with the fact that we're in a sharded address space. So the way that sort of this hierarchy works, and this kind of gets into a meta, these technically aren't different chains. They're all actually sharing a common state root. And it's divided by the first 2-byte prefix, right? So a 00 is sort of the first shard. A 01 addresses the second shard. A 02, so on and so forth. But that means you actually technically have like one state root that you're updating across like the whole system, even though it's technically sharded. It's just which chain has permission to update what part of the state root, right? So that's kind of the complexity that is added. It's just as a developer, you have to use kind of like our tooling because we deal you sharded addresses and correctly. Now, right now, right, this system expands dynamically. So currently, there's only one shard in the system because we're not at 700 TPS yet. The system dynamically understands its uncle rate, and as the uncle rate increases, it allows another shard to take place. So basically, the uncle rate is like it's an indicator that this shard is full and we need another shard. So the system automatically adds shards as the uncle rate gets above a certain threshold for a period of time. So then it just expands. Now, all of the like cross shard interactions, you can do them between contracts, but you have to specify like what your sister contract is. So right now, deploying in a single shard setting, it looks pretty much like a copy paste for EVM like contracts. If you want to support a multi-shard setting in anticipation, then when we shard, you can do that as well. You just have to basically create like a list of sister contracts when you deploy this contract, and then when the new shard gets deployed, you have to deploy the sister contract. But that's about it. So like for 90% of people, unless they're like very forward looking, don't need to worry about the sharding at all. For the other people, they just have to use kind of the tooling that we have to deploy in the first shard.
Gotcha. And yeah, to this point, my follow-up question was whether or not there are any available SDKs or specialized tools for people to pick up and play around with Quai Network.
Yeah, so right now we have what we call Quais. It's a fork of Ethers. It was originally a fork of Ethers 6, V6. We've modified it a bit, obviously, for our purposes. We have like a much better subscription model. Like honestly, like the way the way Ethereum uses endpoints is utter madness. We think we've done a little bit of a better job. So you actually have, instead of like a polling model. So if you use Ethers or use any of like the SDKs, uh, they don't actually use subscriptions. It might look like you're subscribing to something, but like behind the SDK layer, they're actually running a polling on the node. So like if you're like, I want to know my balance, you're just asking a node for your balance every 10 seconds, which is like wild in terms of the amount of overhead that induces on the nodes. We actually have like subscriptions. So like you subscribe to addresses or you subscribe to contracts, and then the like will update you and it'll leave that connection lively, for 30 minutes or whatever, and then you'll have to refresh the connection, but you only have to like refresh it on the timeout. You don't sit here like pulling all the time. So you can lower your request by like 1,000 or more, 10,000x, right? But otherwise, from the user's perspective, it looks pretty much identical to Ethers. It just has our own sort of like namespace.
Right on, right on.
Yeah.
Good stuff. And I guess in terms of like the long-term vision of Quai Network, is there anything that you can share on the roadmap for looking to this year?
Yeah. So I mean, basically, the interesting thing about Quai is, right, we can do stuff we can build applications with Web3 that look like Web2, but we're doing it on a proof of work system, and that proof of work system is scalable. So from a developer's perspective, the reason that Quai is very interesting is because if you look at Ethereum, when it gets sort of a hit application, fees precipitously rise, and that sort of hamstrings that application's growth. So much so that a lot of Ethereum's apps have started to go onto app chains, right? Uniswap being a great example. There's plenty of them, but that's the most recent one. Right. The thing with Quai is, because we can shard, because we can scale, if you're a developer and you build an app, the network grows with your app. And so you're kind of guaranteed this sort of 1 cent per transaction availability today, tomorrow, 5 years. So that's sort of like a super powerful thing. And we've been building applications on Quai that take advantage of that. One such application we have is called Kipper. It's pretty cool. It's like a tipping app on X. You can use it on desktop. There's also you can use it on Android. There's an app. There's a beta on iOS. We're having issues getting it through their store, but it's really cool. You basically can go, if you like, you can set it when you like a tweet, you actually like send somebody one Quai, or you can like tip them and write them a message, and then your reply actually shows up at the top of their feed, kind of like highlighted in things. So but that's just an example of what you can do when you have that like very guaranteed sort of low fee, high throughput system. Another thing that we've done, which is very interesting economically with this system, is called SOAP, a subsidy open market acquisition protocol. Basically what that is we're merge mining with Litecoin, Dogecoin, Bitcoin Cash, and Ravencoin now. And so basically what ends up happening, though, which makes this different from merge mining, is we only pay the miner Quai, and the merge mine token comes back to sort of like a foundation address. That address then liquidates the secondary token to buy Quai at market. So what that does is it actually creates much better proof of work economics for us, because you don't have constant miner sell pressure. But the reason that we can do that is because we're in this very high speed, high throughput proof of work system, and all of these other proof of work systems are much, much slower. So we can kind of take advantage of what we like to think of as underutilized hash rate to increase our security for free. Right. So we basically have like a net neutral emissions at this point, right? Because if we pay out $100 worth of Quai, we're getting $100 of another token back. So like on a net basis, we don't even pay for our security. Like it's free for us. Like we might be paying like 2% or something, but it's like a tiny amount, right? We're also launching something that's kind of an extension of that, where Quai just becomes like a pool, but it can become a pool for any chain that exists. So those are like more examples of applications that you could just build because Quai is high speed and scalable. Yeah.
Yeah, I think Quai Network is, it sounds like quite the beast of a network. And like you mentioned, there's lots of opportunities for people to build on it. I guess from that perspective, are there any grant opportunities or upcoming hackathons or anything like that to make it to entice developers to get on the Quai Network train?
Yeah, so we have grants, we have retroactive grants. So if you go to our docs page, you can find out all about our grants. Yeah, I mean, we have, people who build NFT marketplaces, they build, like Uniswap type things, they build pump.fun type things. Um, there's a couple that we're more excited about, and if someone wants to work on it, that'd be amazing. Basically, one of the implications of SOAP, which is very interesting, is we end up getting loose referencing to the blockchains which we merge mine with. So that actually creates a mechanism by which you could trustlessly wrap any of those tokens in and out of Quai without needing like a custodial intermediary. So basically, like Bitcoin can sort of be wrapped into Quai. Bitcoin Cash can be wrapped into Quai. Dogecoin can be wrapped into Quai, right? So if somebody kind of wants to build that service where you go back and forth between those assets, that'd be super interesting. If someone doesn't do it, we're going to end up doing it, because what we'd like to see is the SOAP revenue we get sort of guarantees volume every day, right? We're doing like 20,000 or so in volume every day in proof of work. So right now we're having to clear that volume through centralized exchanges. But if we can have that wrapping service, we'd like to clear all of that volume through a DEX that runs on Quai. Would be pretty cool. And then the cool part is that volume goes up with our hash rate. And as our hash rate goes up, we get more subsidy, which buys back more token, right? So then our price goes up. And when the price goes up, the hash rate goes up, which gets us more subsidy. So it's this cool sort of virtuous loop of sort of increasing hash and price, which hasn't like ever existed in proof of work. It's always been the opposite, which is, miners mine, they have to sell to cover costs, and it like causes the token price to go down unless you can get more new buyers than you're having to sell to cover your security every day. So like we're really excited about SOAP because it really changes the economic game. I think it actually makes proof of work more economically like robust than proof of stake at that point, because even within proof of stake, you still got to pay 3 or 4% to your stakers. In this case, we're getting security, but like we're net neutral, which is pretty cool.
Yeah, that is pretty cool. And for anybody who's watching today or listening, there's no ton of opportunity on Quai Network. And I mean, building a DEX, that's a money printing machine. So
building a DEX with guaranteed flow. Exactly. So like right now we're doing $20,000 a day between those pairs, right? But if our price goes up again, we'll be doing $40,000 a day, guaranteed every day that like you clear, right? So there's a lot of opportunity there.
Indeed there is. And I guess just before we let you go here, what's the best way for folks to kind of keep up to date with all the latest and greatest from Quai Network and yourself?
Yeah, so they can follow Quai. It's a Quai Network on X. You can also follow me. My handle is Mechanical K, spelled K-A-L-K at the end. If you want to learn about the grants program or you want to learn more about Quai, just docs.qu.ai. You'll find all the resources you need to run a node, develop an app, mine, get a grant. So
amazing. And yeah, we'll have all those resources for you in the description below. So definitely check that out. Get involved in Quai Network, check out the docs, start building things, move over some smart contracts from the EVM world here. And I'm really excited to see Quai Network continue to grow here. And thank you again, Dr. K, so much for taking the time out of your busy day to come chat with us today.
Appreciate it.
course, of course. With that, I wish everybody a very happy new year again. Happy weekend, wherever you may be. And we will catch you back here for another episode of DevNTell next week. Till then, have a good one, folks. If you enjoyed this episode of DevNTell, be sure to subscribe to never miss an episode. Till the next one, cheers.